Hello. I know I have posted a video on reference numbers. This is just a kind of a quick video, a couple more examples. Please yell if you want to see more examples. First of all, remember our distance t is defined to be the distance from the standard position, which is basically the x-axis going to the right, and the terminal side. So that length of that arc there is our measure t. It's positive if the distance from that standard position goes counterclockwise. It's negative if it goes clockwise. So really, when you're doing reference numbers, you have at most 3 steps that you're going to have to do to find a reference number. First, make sure that your measure of t is a positive value from 0 up to 2 pi. So you're wanting a positive number that's within 1 revolution of the circle. Okay, 1 full circle around from starting position. The next thing you want to do is identify which quadrant the t value, the terminating side of the t value falls in, because you treat reference number differently whether you're in quadrants 1, 2, 3, or 4. Okay? And then finally, we'll find the reference number depending on this. So the easiest reference number is the one that's in quadrant 1. Because if you are in quadrant 1, your reference number is the value that's between 0 and pi over 2. It is like your t value, but the t value within 1 revolution. So you want that value first, but it's just that little measure there. What's the distance between 0 and the terminating side? If you're in quadrant 1, once you've completed this step, you have it. So for example, let's say that we have t is 13 pi over 6, okay? Now, a value of 13 pi over 6, remember, when we are talking about between 0 and 2 pi, we want the number that's going to be between 0 and 2 pi. We have an over 6. So if we want that to be over 6, how can you write 2 pi as a fraction over 6? Well, 12 divided by 6 is 2, so that would be a 12 pi over 6. 0, 0. Notice 13 pi over 6 is not in this interval of values. So what we're going to do first is get a measure that is really complementary to this, corresponding to this. What would happen if I decreased, because wherever your angle is, what would happen if I decreased, because it's too big, it's bigger than the 12 pi over 6. So what if I decreased by 1 revolution? 1 revolution is a measure of 2 pi. So I'm going to take my t value of 13 pi over 6, I'm going to decrease it by 1 revolution, which is 2 pi. That's a 12 pi over 6. And that is just a 1 pi over 6. So our first step, pi over 6 is in the interval 0 to 2 pi. So first step done. Now, which quadrant is that in? Which quadrant is that in? Well, the more comfortable we are with these common distances, the more we'll see it. Pi over 6 is in quadrant 1, but you might have some weird ones. It might not be a regular angle. So this is what I always do, especially if you have a really odd value going on here. This is 0. This is pi over 2. This is pi. This is 3 pi over 2, and then a full revolution is 2 pi when we're starting at 0. So what you can do, and let me grab the calculator really quick. If you go pi over 2, that is approximately 1.57. Pi is approximately 3.14. 3 pi over 2 is approximately 4.71. 2 pi is approximately 6.28. So when we look at this, what about pi over 6? Pi over 6 is approximately 0.52. So if you look with these numbers, 0.52 is between 0 and 1.57. It's somewhere down in here, okay? So pi over 6 is somewhere down in here. It's in the first quadrant. This is in quadrant 1. If you are in quadrant 1, your reference angle is the distance between the x-axis and the terminating side. Well, what's going on here? Here's the x-axis, that's the 0, and here's our terminating side. Notice that is that distance of pi over 6 that we had found. So our reference number is pi over 6. So if you have a t-value of 13 pi over 6, going through these steps, our reference number is pi over 6. Reference number, and I said angle, but reference number, we'll see eventually angles are the same thing here. The reference number is the distance between the x-axis and the terminating side, okay? Think about these 3 steps. I'm going to do some more examples here, but think about these 3 steps. Think about your unit, about the circle. So 0, pi over 2, which is approximately 1.57, pi, which is approximately 3.14, 3 pi over 2, which is approximately 4.71, and 2 pi, which is approximately 6.28. Think about that circle. Remember, you're always starting standard position at 0. Remember that reference number is the smallest distance between the x-axis and the terminating side of t. So again, it depends on the quadrant. Let's look at a few examples here. So for example, if we have, and we could do, we're dealing with distances in t. Lots of times we have pi's involved. Sometimes we'll just have the numbers. So example, I want to find the reference number of t equals 9 pi over 15. Well, first of all, 9 pi over 15 will simplify. 3 will go into both of these. 3 will go into 9 3 times and 15 5 times. So this is 3 pi over 5, okay? Our first step, we want a measure that's between 0 and 2 pi. Well, it's already positive. So this means it's bigger than 0, means it's positive. 2 pi, if we're dealing with over 5, that would be a 10 pi over 5. 3 pi over 5 is in that span, so we're good. 3 pi over 5 is there. That first step's done. Second step, what quadrant are we in? The easiest way to do that is estimate 3 pi divided by 5. 3 pi divided by 5 is approximately 1.88. Look at our circle here. 0, this is 1.57, this is 3.14. 1.88 is bigger than 1.57. It's definitely not up to 3.14. That's somewhere up in here. We're in quadrant 2. So we know we're in quadrant 2. So let's think about this as we go to get our reference number. We know that we're given a value t. I'll do it here. We're given a value t of 3 pi over 5, which puts our terminating side in quadrant 2. We want the shortest distance from this terminating side to the x-axis. Now your x-axis is right here, okay? Here's your x-axis. We have two options. We have this distance from the terminating side to the x-axis, which is 3 pi over 5. But then we also have, I should have gotten a different colored pen here and play with, but I didn't. So this distance here, this distance is shorter than this one. So what we want, our reference number needs to be this distance right here. Well, how can I get this distance? I know that the distance from the very beginning all the way over is pi, okay? I know that the distance from the beginning to right here is 3 pi over 5. I want this. That's the difference between those two measures. So our reference angle, or our reference number, is going to be the difference between these. So always take the larger minus the smaller. Pi is the largest distance minus that smaller distance of 3 pi over 5. Pi as a fraction with 5 can be written as 5 pi over 5. 5 pi minus 3 pi is a 2 pi. That's a 2 pi over 5. There's your reference number, okay? Anytime you're in quadrant 2, you're always going to have that larger distance of pi minus the smaller distance. I'm going to say the t that's between 0 and 2 pi, okay? You want to have converted it to that value in the first step. That's what we do there. That's quadrant 2. Let's look at another one. What if we had, let's find the reference number for t equals negative 7 pi over 8. Okay. Negative acts a little differently, right? If we are here, starting, here's our x-axis. We're starting at this standard position. The negative tells us we're going this direction. So we're going clockwise this direction. A measure of 7 pi over 8. Well, think about this. Our first step, we want to measure between 0 and 2 pi. Now, I can look at this. This will be negative pi over 2. This will be negative pi. That's negative 8 pi over 8. It's down here somewhere, okay? There's our negative 7 pi over 8. But in order to find reference numbers, what we want to do, first step, is we need to know the corresponding number that's between 0 and 2 pi. So what's going to happen if I take this negative 7 pi over 8 and I go one revolution around, I increase it, I go counterclockwise one revolution around. So I'm going to increase negative 7 pi over 8 by one revolution. That is negative 7 pi over 8 plus 2 pi. We have a denominator of 8, so that's negative 7 pi over 8 plus 16 pi over 8, since 16 over 8 is 2. Negative 7 plus 16 is a positive 9 pi over 8. So a t value of negative 7 pi over 8 has the same terminating side as a t value of 9 pi over 8. They end up in this same position, okay? So that's your first step. Get a value that's within one revolution of a circle. Now, what quadrant are we in? I've already drawn this and kind of shown you that's in quadrant 3, But again, what you can do is if you estimate 9 pi over 8, 9 pi over 8 is approximately 3.53. Now remember, let me go back to my original circle here. Pi is 3.14. 3 pi over 2 is 4.71. So 3.53 is going to be somewhere in between the two, closer to here. So what we have going on, and I'm just going to sketch the circle again since I've written so much on the other, is I know that I'm somewhere, this t value right here of 9 pi over 8, okay, is the distance from standard position over to this terminating side. We're in quadrant 3, okay? Remember, when we want the reference number, okay, we want the reference number, we're trying to find the shortest distance to the x-axis. Well, look at this. If this is where you're terminating, you have two options. Your distance to the x-axis can be over here to get to this part of the x-axis, or it can be this little bitty distance here to get to the x-axis. We want the shortest. So we're actually wanting this distance right here, okay? This little itty bitty distance right here is our reference number. Well, think about how we can get that. We know that starting at 0, if we go to the other side of the x-axis, that's pi, okay? We know that our larger distance is 9 pi over 8. So to get your reference number, take the larger distance minus the smaller. So our larger distance was the distance to the terminating side, 9 pi over 8, minus the shorter distance, which is just to the x-axis, that's pi. So that's going to be 9 pi over 8 minus, pi can be written as 8 pi over 8. 9 minus 8 is 1. So that's just a pi over 8. Pi over 8 is our reference number for that one. It really does depend on the quadrant you're in. Once you've gotten a value that's between 0 and 2 pi, and you identify your quadrant, then that distance is all going to depend. If you are in quadrant 1, okay, your t value between 0 and your terminating side is right here. That is the shortest distance to that x-axis. So your reference number is equal to the t value that's in the range 0 to 2 pi. Okay, so after you've done the first step. If you are in quadrant 2, somewhere over here, here's your t. Okay, there's your t. That's going from 0 to the terminating side. Remember that your x-axis here, if you go all the way to the left side of the x-axis, that's a distance of pi. So your reference angle there is this distance. So your reference number is going to be the larger minus the smaller. That's going to be pi, which is the distance all the way over to the x-axis, minus that part that we don't want, which is the t. That's if you're in quadrant 2. Okay. If you are in quadrant 3, and that's the last example that I did. Quadrant 3, your terminating side somewhere down here. So your t value that you get between 0 and 2 pi is right here. We know that the x-axis, as you go to the left, you have a distance of pi that goes from 0 to the x-axis to the left. So if you're wanting that little bitty distance right here, okay, you're wanting this short distance right here, Again, to get that reference number, take the larger distance minus the smaller distance. The larger distance is the whole distance around, which is your t, minus the distance to the x-axis, which was pi. Okay. And finally, if you are in quadrant 4, okay, so our terminating side somewhere down here. Our distance t is right here. Between 0 and 2 pi, you have to have it converted to that first. Remember your x-axis, if you're going to the right, that x-axis is either 0 or 2 pi, depending on if we've revolved around or not. And then the distance to the left is pi. So let's look what's going on. If our t falls in quadrant 4, the closest distance to the x-axis is right here. So we're going to take, to get our reference number, the larger minus the smaller value. The larger value is all the way around 2 pi, minus the smaller value, which is the distance of t. So these are the ways, your first step, we need that value to be between 0 and 2 pi. Now, when it comes to your answers on the test or your answers on your homework or your quizzes, if the problem does not say to round your answer to the nearest 10th or 100th or whatever, then it wants an exact answer. So that means it wants pi over 8, or it wants, you might even have to go something like 2 pi minus 3.5. It just depends on what you're given for the values, but try not to estimate unless it asks. The estimation that I used in the problems was actually when I went through just to figure out the quadrant it was in. That way we could have an idea of what we were dealing with, okay? So hope that helped. Please let me know if you have any more questions. Thanks.